Well, hello, we're jumping into 2.6, which is solving absolute value inequalities. It's taking everything you love about absolute values and inequalities and putting them together. So absolute deviation is a term that you're going to see in this. We'll discuss what that means in a bit. And then we've already talked about compound inequalities, and mean, hopefully you remember, is basically an average. It's when you add up the numbers and then divide. So that's what we're dealing with today. Let's jump into some notes if you'd like to take some notes. So an absolute absolute value inequality is an inequality that contains an absolute value expression. So if you have like the absolute value of x is less than 2 and the absolute value of x are greater than 2, those are absolute value inequalities. I'm just reading this word for word. And recall, absolute value is the distance from 0 on a number line. It's always a positive number. So here, if you have the inequality absolute value of x is less than 2, it means the distance between 0 and that point has to be less than 2. So you can graph that right here. That's what this graph looks like for this inequality. And then if you have the absolute value of x is greater than 2, it means the distance between 0 and x has to be at least 2. So this would be a divergent graph like that. Okay. So this is a good spot to take some notes. It also has the general formulas right down here for absolute value inequalities. You might want to go full screen to be able to view that a little better. This is also available on the digital version. Okay, moving on to some problems now. So first, solve this inequality. The absolute value of x plus 7 is less than or equal to 2. When we solve this, we're going to have to set up two different inequalities. What do you think those two inequalities are? Okay, where's my little next button? There it is. Okay, so the two different inequalities are one where this is less than or equal to negative 2 and one where this is less than or equal to 2. So just like when we're solving equals sign absolute values, you got two different situations, one where it's greater than, one where it's less than. Notice here, this absolute value sign here for the negative, it flips the old puppy around here. So that is the one trick to this. For our negative value, we turn the absolute value sign around. Okay, so then we solve each of those by doing the same steps, subtracting 7 on each side, and you end up getting x is greater than or equal to negative 9, and x is less than or equal to negative 5, which we can then graph. Will we use open or closed circles when we graph these? Yeah, closed circles, because they can be inclusive of those points. So there we go. Closed circle on 9, or negative 9, closed circle on negative 5. And it's the points in between those two values. Okay, so there we go. Oh, and then we're already jumping on to B here. So if you have a problem like this, the absolute value of anything is less than 0 or is like going to be negative, you know that cannot be true. So absolute value of an expression must be greater than or equal to 0. Therefore, this cannot have a solution for B. Okay, so keep that in mind. Some of these will have no solution. All right, let's jump into some more examples. Ooh, there's 3 of them. Try and solve A without any prompting at all. I want to see what you got on this one. So try and solve A. Go for it. All right, let's see how you did. Let's walk through A. Okay, so you're going to set up two different inequalities. One, when you have a negative 5, you switch the sign around here. And then the other one is just solving this, dropping the absolute value is greater than or equal to 5. So when you solve, you add 1 to each side, and you end up getting this or this. So when we graph our solution, we end up with closed circles, and it's divergent because C has to be less than or equal to negative 4, so it's going to the left, or greater than or equal to 6, so it's going to the right. Okay, so hopefully you did well on that one. Now let's try B. Try and solve B. See what you got. All right, so same deal. You would try to set up two different inequalities. However, it says, where am I? Oh, yeah. All real numbers are going to be solutions. Now, I kind of wish that, does it walk us through it? They're not going to walk us through it. When you solve this, you're going to do one where 10 minus m and then switch the sign around is less than or equal to 2 because the negative version of this is actually a positive number. And then you're going to have a second one where you're solving it just like this. You'll find out when you solve both of them, they actually overlap, including all possible numbers. So they've explained it here in words of why it has to be all real numbers. You can actually solve it as two separate inequalities and find out when you graph them, they overlap, and it includes the entire number line. Okay, so for C, just for sake of time, let's walk through this. What's a good first step? Yeah, subtract 1 on each side. So first, get rid of that. And then again, before you drop the absolute value and do a positive and negative, what should you do next? Yes, next divide by 4 on each side, and now you've reached this point. This is where you will now write up two different inequalities. So for our 2x minus 5 and negative 5, will we keep the sign greater than or switch it around? Yeah, we switch it around for the negative version. Okay, so don't forget, switch the inequality sign around when you're solving the negative version of the absolute value. And then this one we solve exactly as is. You add 5 to each side to solve each of these. You end up with 2x is less than 0, which means x is less than 0. And here you end up with x is greater than 5. So if x is less than 0, x is greater than 5, will this be a convergent or divergent graph? Yeah, this one's going to be divergent. So open circles, and the arrows are going opposite directions because it's less than 0 or greater than 5. Okay, we also have some story problems. So here we have this computer problem. I think for sake of time, I'm just going to let you pause and read, and then we're just going to go through the solution. Okay, so the main thing on this is to come up, so for some of these problems, you have to create your own inequality, absolute value inequality. So this is where the mean comes in. So in order to write an inequality, I don't know if you remember when we did the equal sign absolute values and you had to find midpoint, that's basically finding the mean. So the mean for this is all 10 of these divided by 10 is 664. And then we want this to be at most $100 from that mean. So it's the price minus the 664 has to be less than or equal to 100 because we want it to be at most $100 off. And then you will have two different inequalities that you can solve. So one was where x minus 664 is greater than or equal to negative 100. That's this part. Or one where it's just x minus 664 is less than or equal to 100. That's this part. That's your two different inequalities. And when you solve, you get that between 564 and 764. Okay, so 6 of these prices meet those conditions. So you will have some story problems. This is about as complex. I'm going to try. Ooh, look at that. No, I don't. This is about as complex as you'll see in the story problems. Anyway, some of these you may struggle with. Just ask for help as you're working through them. And good luck on these. The main thing is when you set up your two inequalities for the negative version, turn the sign around. That's the big difference between this and when we did equal sign. Okay, good luck. See you in class. All right.